Hello, in this video, I will explain to you on how to find V1 and V2 in this circuit by using nodal analysis. So what is V1 and V2? V1 and V2 is this voltage here and this voltage here relative to the ground. Okay, so we have three nodes here, node V1, node V2, and the ground. Okay, let's put some dots on there. So we know which one that we are talking about. This is for V1, this is for V2, and this is for the ground. And what we know is we assume that the voltage in the ground node is always 0. And that is the definition of the ground. So the voltage here will be 0. Remember that whenever you see this symbol, it means that the voltage there is 0. And then the next step is assuming all the direction of the current. So in this step, we define the direction of the current. We don't know it yet, but we define it, right? So in this resistor, I will assume that it will goes down, and this resistor, it also goes down, and this resistor, it also goes down, and then this one is also goes down. No, it goes to the right, right? But then we also have the current source, and for the current source, I usually use the direction that is given by the current source. So it clearly said that the arrows goes to the right, so we just follow it there. Because in this branch, the current is fixed, right? That will be 6 ampere. It never change in this branch. And it's also the same here for this branch, that is 3 ampere going up in this branch, right? So what we need to do is we need to do KCL at V1 and also KCL at V2. Okay, let's start from KCL at V1 here. So let's do exactly that, KCL at V1. What does KCL say? KCL said the current that goes in, all the sum of the currents that goes in, is equal to all the sum of the currents that goes out, right? So we can put it like that. So we will have this formula here. Now in V1 here, which current going in? I think all the currents is going out from V1. So we can just put 0 for the current that goes in, right? And then let's do the currents that goes out. There are 1, 2, 3, 4. 4 currents that goes out. The most obvious one is this one here, which is 6 ampere, right? So 6 ampere going out from V1. So I will have 6. And then we have this current here that is going down. But then we don't know it yet. But then we can calculate it using Ohm's law. Remember, the Ohm's law said that the current is the voltage divided by the resistance. But then the voltage is the difference between this node and this node here. So I will have V1 minus 0, right? The current is flowing from V1 and it goes to V0. I mean the ground. So I will have V1 minus 0. And in between, we have this 10 ohm resistor. So I will have 10 here. Then let's move on. So I will have the second current, I mean the third current, technically. So I will have this one here. So we can play the same game. So I will have V1. So the current comes from V1 and it goes to the ground. So I will have again V1 minus 0. But then the resistance between them is 5 ohm. So I will have 5 here. And the last one, I will have this one here. So I will have plus V1. The current comes from V1 and the current goes to V2. So I will have minus V2. And divide that by the resistance between them. So I will have 2 ohm, right? Okay, so the next step is I want to get rid all of the denominator. So I multiply both sides here by 10. Why 10? Because it cancel out with all the denominator, right? 0 times 10 is just 0. 6 times 10 is 60. And this 10 will cancel each other. And V1 minus 0 multiplied by 1 is just V1. So I'll have V1. Okay. And then 5 and 10 will cancel into 2. So I will have plus 2 multiplied by V1 minus 0. So that will be 2V1. And then for the last one here, I will have 2 and 10 cancel into 5. So I will have 5V1 minus 5V2. Okay, we can just do simple algebra here. 1 plus 2 plus 5, that will be 8V1. And then minus 5V2. I think I made some mistakes there. So I will have V2 minus 5V2. So I have minus 5V2. Then let's put this 60 to the left hand side. So I'll have minus 60, but I will write it here. Minus 60. Good? Okay, that is our first equation. Good, now let's move on to V2. And we can do the same game, right? Now let's do KCL at V2. KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, what is the current that goes in? We have this 6 and this 3 going in, right? So I will have 6 plus 3. Let's write it first. And then we also have this current here that also goes in. And that will be, the current comes from V1 and the current goes to V2. So I will have V1 where the current comes from, and then minus V2 where the current goes to. Divide that by the resistance between them, so I will have 2. And then that will equal to, the only current that goes out is this one, and that current is V2 minus 0 divided by 4. Okay, I think I can simplify this, right? Let's multiply both sides by 4. But then 6 plus 3 is 9. 9 times 4 is 36. So let's write 36 first. And then 2 and 4 will cancel into 2. So I will have 2V1 minus 2V2. Good. And then 4 and 4 will cancel each other. And then we will have V2 minus 0. That will be V2. Good. And now what can we do here? Let's move this to the left hand side. So I will have 2V1 minus 3V2. And that will equal to minus 36. Good. Now we have our second equation. So now we have equation number 1 and also equation number 2. And we can just solve this, right? And the fastest way to solve that is by using calculator. So let's start using calculator. And let's set this up as equation solver. So this one, and number 5 is equation. And 2 variables is number 1. Let's plug that in. So I will have 8. And then minus 5. We can just plug in the coefficient. And then minus 60. And then we will have 2V1 here. So I will have 2. And then minus 3. And then minus 36. And from here, we can have our V1 here, which is 0. So I will have V1 here is equal to 0 volt, which is our X value. And then what is our V2? Our V2 is 12 volt. So we'll have 12 volt here. And I think that is the answer for the question, right? Because the question asking us for V1 and V2. So hopefully I did not make any mistakes during this calculation. Thank you for watching and see you in the next video. Bye-bye.